and working problems in my head and getting them wrong, but still doing it. I mean, like a boss. All right. So, question. Let me just go through test 3. All right. I'm going to post this link on. I'll post it on Canvas. Number 1. For this semester only, because of the hurricane day. For this semester only, because of the hurricane days, you may use one 3 by 5, one 3-inch by 5-inch index card. That can be lined or unlined, depending on how you like to write. You may use one 3-inch by 5-inch index card, handwritten. Don't get an 8.5 by 11 sheet of paper and then try to cut out the edges, because that ain't a damn index card. Some of y'all like, I don't have an index card. You know what? Walmart sells them for like 85 cents for a gazillion pack. All right? Get yourself, go to Walmart, buy yourself a pack of index cards, grab 3 or 4, take the rest of them back if you need to get the money back. All right? Walmart takes everything back. We all know that. So, one 3 by 5 index card, handwritten, doesn't have to be your handwriting, because some of y'all's handwriting sucks. So, get your mama. Say, Mama, I need you to write this stuff down for me. All right. Some of y'all like, I'll get my girlfriend, I'll get my boyfriend. I don't give a damn who does it. One 3 by 5 index card. Question 1 is definitions. Question 1 is definitions. I don't know how to do that. We'll get rid of that shit. All right. Question 1 is definitions. Question 1 is definitions. Go to YouTube, type in my name, type in the playlist, test 3 definitions. That's question 1. Question 2 is central limit theorem. Let me walk you through the central limit theorem. Somebody asked me yesterday, what do I need to know about the central limit theorem? It's all in the video, and I'm going to tell you right now what you need to know, so you don't even have to watch the video anymore. All right, here's what the central limit theorem says. If you take a relatively large sample, the sample means will approximate a normal distribution. If you take a relatively large sample, the sample means will approximate a normal distribution. Okay? That is a lot of statistics speak. All right? The students are like, I don't know what the hell you're talking about, but I'll write it down. If we take a relatively large sample, the sample means will approximate a normal distribution. All right? That's a very big deal. And it only occurs if you take a relatively large sample. All right. Now, at the volleyball game, when I'm giving away chicken sandwiches, I try to find various crazy ways to give them away. I bring people out. If you can do a cartwheel, I'll give you a chicken sandwich. If you can do a flip, I'll give you a chicken sandwich. One game I said, the first person to bring me a quarter can have a chicken sandwich. And you see people racing through their pockets trying to find a quarter. Does everybody know that a quarter or a nickel or a dime or a penny has a date on it in which it was minted? Everybody knows that? All right. If everybody pulled out a coin, do we agree that the date would vary widely amongst everybody? Somebody might have 1998, somebody might have 2022, somebody might have 2015. Like, it would vary widely amongst everybody, right? And if instead of looking at one coin, we looked at 7 coins, does it make sense that if you looked at 7, then everybody would start getting closer to the same numbers? They wouldn't get the same number, but they would all start to balance out, a low one might balance out a high one, and they would start balancing out some, and those numbers would start coming closer together. What this central limit theorem says is if you take a large enough sample, those means will start to balance out. The definition that the central limit theorem uses is large enough is greater than 30. And so what the central limit theorem says is, and I'm going to say this slow, if you take a relatively large sample, and by relatively large we mean n is bigger than 30, the sample means will approximate a normal distribution. The sample means will approximate a normal distribution. Now, if that's what it means, why do we care? We care because if you take a large enough sample, you don't need to know whether or not the population is normally distributed. It won't matter. The sample means can be normally distributed without knowing the population distribution. That's a pretty big deal. I know in your world it doesn't feel like a big deal. In my world, it's a really big deal. Anytime you can work with a sample and you don't have to be concerned with the population, that's a big deal. Now, there are a couple corollaries you need to know as it relates to the central limit theorem. Number one, the mean of the sample means is equal to the mean of the population. The mean of the sample means is equal to the mean of the population. Meaning, if you do enough samples and you take the average of all those samples, that average will be the average of the population. The other thing it says is, and this is a big deal as well, the standard deviation of those sample means will be a function of how much the population changes divided by the square root of n.
Is that first mu or
That would be mu, and that's your first warning. Because if you call it u or m, then you fail the class. Do you remember that? Okay. We talked about that. Very important, very important. First warning. You only get 400. People are like, holy shit, he's got 399 left? Thank God I didn't say it. No, you're good, baby. The first mu, so what we're talking about here, Joey, is you take a sample of, say, 40 coins. Now you become sample mean 1. Brandon takes, hold on, my bad. Aha. People watching at home. Brandon takes a sample, 40 coins. He becomes sample mean 2. Okay? And everybody does this, right? Everybody's going to do it, right? So you're going to get a bunch of these different samples. What the central limit theorem is saying is, if you take the average of all of these, that average will be the average of the population. All right? Yes?
What did you say about the standard deviation?
Now, how much variation is there between this value, the next value, right? Because they're not all going to be the same. There's going to be some differences there. How much difference is there? That's measured by the standard deviation of the sample means, and that's a function of the standard deviation divided by the square root of n. All right? Does that make sense? All right. And again, it's a big deal because it allows you to find the sample mean being normally distributed without knowing the population distribution. That's a really, really big deal. Again, for you, you're never going to use it in your life probably. You're just trying to graduate. The rest of your life, the central limit theorem will have no effect on you. For people who do this stuff, it is a majorly important thing. It's like the most important theorem in all of statistics. Okay, like it is a really big deal for me. Like it was life changing. I'm not going to lie to you. When I first saw it, life changing. That how much does this value deviate from this value, which deviates from this value, which deviates from the next one? That's a function of two things. Number one, how much deviation there is in the population to start with, and then how big the sample size is. See, if everybody takes like 1 million samples, then at that point, everybody's answer is going to be pretty much the same. Right? If you take 5 samples, it's not going to be the same. If you take 500 million, pretty much at that point, everybody would get the same answer. Because you just made such a big, you just found such a big sample for it. Okay. All right. Let me just lastly, Joey, I was giving you a hard time. Please don't think you're going to fail the class because of you. That's not going to happen. But if you do leave this class and they ask you who you had after you called it you, tell them Lee Joe. Just don't even put my name in your mouth. I'm not taking credit for that. Okay, we're on YouTube. Live. Go ahead. What's that?
What's the N mean in that formula?
N is the sample size. N is the sample size. We actually already have. And when I get up to YouTube, I'll show you. We've already done this. You just didn't know that it was called central limit theorem. I didn't tell you that part. Yes? If we take a relatively large sample, the sample means will approximate a normal distribution. That's what the central limit theorem says. The sample means will approximate a normal distribution.